All right. So amazing conference, flying taxis, race cars, pretty cool. So I hope you're having a great time and networking and getting super excited about data and AI. If you haven't seen like the Genie space demo, definitely worth looking into. Now here's an obligatory slide. I don't think I have any like forward-looking statements, but if I do, please know they are subject to change. And let me just state the obvious here. So Databricks is a little obsessed with data. So if you at the end of this can rate me, that would be great. If you like the content, give me a high grade. And if you like the support staff who help with the display and the audio, give me a high grade. So thank you very much. So I'm Craig Lukasik, based out of the Raleigh area. I'm a specialist solution architect at Databricks. And today I'm excited to tell you about the new PySpark custom data source API. And I want to tell you how it helps the lives of not just the data engineers, but also the architects and the managers. This new feature hopefully can help you build reusable components for those non-standard data sources. We were talking about that a little earlier. And before we go into the new feature, I just want to tell you about the origin story. So every Apache Spark feature originates from the Spark community, and many of whom are Databricks engineers. Many Spark improvements originate from what we at Databricks hear from our customers. So we hear things like, hey, we got to ingest this streaming data or this batch data, these fixed width files. And it's not a standard source. It's not Parquet or CSV or Kafka or Kinesis. It's something else. We have IoT devices, real estate devices, energy devices. And so getting the data, and likewise, there's the same story on the other side of the pipeline. Getting the data out to custom syncs, that was another pain point. So we listened, and our PMs and engineers, they're pretty methodical about listening to our customers. Our mission is to democratize data and AI. And we like to hear so much about what your pain points or frictions are that we even have instructions on our documentation on how to give feedback and add to our roadmap. So like many features, this Python data source origin story started with that customer feedback, and it eventually took shape in Apache Spark 4.0, although this is an old slide, as you can see, because I think it's no longer preview. Before we go into this PySpark custom data source, I want to revisit some concepts. Most of you probably know the difference between batch and streaming, so I'm not really going to spend time on this slide. But here are some other concepts that are sort of foundational when it comes to structured streaming. So I'm going to go through these with you. So first up, we have this concept of partitions. All right, the word partition is a little bit overloaded in Apache Spark, but for streaming, for our demo, think of it as the partitions in the source system. And it's kind of just like Kafka or Kinesis. So think of this as a way to divide labor, a division of labor. A data stream is sliced into smaller, manageable segments, and Spark can process these segments in parallel. This is key to achieving high throughput, and it's an important concept to understand when using this new API, especially if you're doing the streaming or you have high volumes of data. So different systems have different names for these source partitions. Kafka has partitions, Kinesis has shards, tomato, right? It's all the same. But the mapping from the source system's partitions to Spark's input partitions isn't always one-to-one. So just to complicate it a little bit more, you got the source system partitions, and you got Spark input partitions. So if you use Kafka to ingest into Databricks, there's an option called min partitions that will actually have a single Spark input partition reading from multiple Kafka partitions. And that just can give you a little finer control over your job's parallelism. In the demo we'll show later, it'll just be a one-to-one, nothing too fancy. So that's our first concept. The next concept is offsets. And this slide calls it a to-do list. So for each microbatch, Spark is querying the source system, or you can really, in this custom PySpark data source, you could have custom logic that figures out the range of data that it will process from each partition, from each source partition. So for instance, it might determine, for this batch, I'll process records 101 through 200 from partition number 1. So this range is defined by a starting and ending offset, and this to-do list is created before the batch processing typically begins and is stored in a write-ahead log. So if a single task fails mid-batch, Spark can use this to retry the exact same range of data, ensuring no data is lost or recalculated. And again, different systems have different names for it. Kafka has offsets, Kinesis has sequence numbers, potato, right? It's all the same. And then finally, there's the concept of commits. This is the done log. You can think of it as a done log. After a microbatch successfully processes its data and writes to its destination or the sink, Spark records the completed batch number in a commit log. And this log simply notes that the to-do list for that batch is finished. And its real job is job level fault tolerance. If your entire streaming application crashes or restarts or using like the available now trigger, it'll first check that commit log when it restarts. So if it sees that batch 123 was successfully completed, it will start the new run from batch 124. And when I talk about batches, this is Spark operates in this micro batch mode, and the micro batch mode can have a number of records. So some other systems are more record by record. Apache Spark, I think a lot of people here are familiar with it, is micro batch based. And so this mechanism really helps prevent that data duplication, and it's critical to achieving end-to-end exactly once or at least once processing guarantees, and it really depends on your sync logic. And this also enables other actions. So with this custom PySpark API, data source API, you'll have an opportunity to write a method or implement a method called commit. And in that commit method, you might do something, say if you're going to a wellhead to get some API data, and that wellhead has maybe a little bit of onboard historical memory. In that commit method, you can go ahead and maybe hit the API that clears that historical memory. All right. So those are the concepts. All right. Now let's, before we go into a demo and look at code and whatnot, let's imagine a scenario. All right. So you just joined a hot new startup. And the startup builds some AI-based tools for developers. Right? So it's super cool, super cutting edge, you're super excited. You're at a startup. Startups are fun. How many people here? Raise your hand if you're at a startup. Awesome, isn't it? Yeah, but the reality, so on day one though, usually your boss gives you something that needs just sort of data engineering basics, right? So your goofy boss says that you need to help with a bunch of teams that need to pull in data from GitHub. So your boss says that you need help to help out these various teams across the company, and they need the pull request data from GitHub. And if you don't know what a pull request is, I think everybody here probably does, but think of it as a change request So when a developer wants to update a code base, they submit a pull request or a PR, and that will be reviewed and merged into the main code base. Hopefully it's reviewed and approved. So remember, we work at a startup, and we're selling these services to developers, and these PRs will be used by the startup's fancy AI engine. So it might, for instance, send an automated message to a developer with a teaser analysis that looks at their PR and tells them what they think about their code submission and what they can change. So you're about to tell your boss, you know, I don't have to do anything here. So GitHub has, I think I have a laser pointer. GitHub has an API. You almost tell your boss, yeah, that's easy. Those teams can just use that REST API, and each pull request can be retrieved. So you can see the API there. That's the identifier for the pull request. And so think of it as just a sequence number, or maybe an offset. So before you respond to your boss with that sort of gut reaction, you remember some of the training that you had earlier that day. Now the founders of these startups, they're goofy folks, right? So they grew up in the 80s and 90s, and they have some very clear cultural principles that were part of your onboarding training. So you remember the training video that was part of your onboarding, and an image comes to mind. Right, so the company values reuse. Anyone grow up in the 80s and 90s? No, a couple. All right, I'm pretty ancient. But anyway, it was a big thing. Hopefully you still reuse and reduce and recycle. But anyway, so the company values reuse. It wouldn't go over well if the teams that need that PR data had to wrestle with the GitHub API and roll their own solution. So you want a reusable solution. Likewise, think about the effort each team would need to make their own implementation for their PR retriever. So that's development, testing, versioning, etc. So you want to reduce that effort across the teams. And your immediate goal is going to involve helping the team that needs streaming PR data. With an object-oriented approach, you would allow others to extend your implementation and perhaps add support for batch workloads. So to recap in sort of more modern terms, we want to aim to build composable solutions that can be independently developed and tested and reused across the company. So just to recap, so some teams need batch data. Some teams need maybe some streaming support. And this is a perfect sort of scenario where this custom PySpark data source API can come in handy. And this is what it looks like. It's really sort of simple at the high level. It can be a little complex at the low level, which is why we went through those concepts earlier of offsets and commit and partitions. But at the high level, from a programmer's perspective, the API is simple. You have a top-level data source class. That's in the step one there. And then you have one or more supporting classes, and those classes really depend on what you need. So if you need to support batch, there's a method that you would implement that returns a certain type. If you need to implement streaming ingest, and then flip side for the syncing. The second step is you register your class, and that's it right there, spark.datasource.register. And then I think the beauty of this is, like, once it's registered, this source just acts like any other like data source that we're used to in Apache Spark. So this spark.read, spark.read, everybody knows that, or yeah, I think everybody knows that more or less. If not, you should know that if you're using PySpark. Or spark.read stream, or the data frame write, or data frame write stream. And this format here is the name that's returned from a method of your class. So once you, on ingest, once you have that data frame, it's just like any other data frame you work with. You write it through transformations, have all sorts of fun with it. All right, so to repeat, depending on your requirements, your custom format may support streaming and or batch, and it may support reading from a source and or writing to a sink. Now in the code for this demo, we will be just looking only at the stream reader implementation. And this means that our custom format will only be usable with spark.read.readstream. And how you use the API, it's going to depend on your use case. So if you remember only one thing from this talk, whoops, I think I got ahead of myself. How do I go backwards? Oh, yeah, it's this one. Yeah, so if you remember only one thing from this talk, it's really this here. And that's, the URL is not there, but that is the Databricks doc. And so the data source is the base class. So that's really that top level class that you really have to implement in all scenarios. The name is the name that will be used in that spark.read.format, my special format, or my real estate API data. The schema, where is this little? Oh, there we go. So the schema, and the schema can be either in like the DDL format schema or the like the struct type schema. So those are the really key elements, and then these are the parts that are variable depending on your use case. Now, there's sort of two stream readers. We're going to do the top one in the code that we look at. So that's the stream reader that is partition aware. But if you have like a simple data source, maybe not a ton of volume, there's another class that sort of just simplifies it for you, that if you, essentially would be pulling it down in a single Spark task. So if we go back to our concepts, let's sort of relate that to Spark a little bit. So Apache Spark, you've got a query or some sort of action. That action gets broken down into one or more Spark jobs. Those Spark jobs get broken down into one or more stages, and then each stage is composed of one or more tasks. So in the simple stream reader, oopsie daisy. In the simple stream reader, you'd probably just get, or not probably, you'd get one task to pull in the data. But if you have a lot of data volume, a lot of source partitions, then that stream reader, the top one, will allow you to then, when you look in the Spark UI, everyone here good at navigating Spark UI? Yeah. The Spark UI, it took me a while to figure out, and there's a great doc, a Databricks doc, I think maybe within the last year or two, somebody put it up there. I think it's like debugging and optimizing costs with the Spark UI. And that is my best friend because it's tricky to navigate the Spark UI, but once you get those concepts and you can map it to this concept of jobs, stages, and tasks. So the stages have one or more tasks. And then when we map in these concepts that we talked about earlier about the partitions within our source, then we can see when we look at the cluster that if we're using the stream reader, we'll see multiple tasks pulling in data in parallel. All right. So now I'm going to try to bring some code up, and I might wrestle with this for a moment, so bear with me. Take a stretch, and let's see here. About this. So let's see here. Is this running still? All right, good. So for this demo, I'm actually not going to access the GitHub API. It does have a rate limit. You can be crafty and implement logic in your custom PySpark data source to deal with that rate limit, but then it would make for a pretty sort of gnarly demo code. So I've got a little simulator that's just faking pull request data, and I was just making sure that's running. And then here's our trusty Databricks workspace. Oh, sorry about that. I'm just going to give us a little bit of real estate here. And we will look at the code. And let's see here. Should I zoom in? All right, let me zoom in a little bit. Good enough? Good enough. All right, so we don't have to read all this stuff, but basically it kind of explains our scenario. We're at this AI startup, and we need something that's reusable and sort of brings elegance to the end user. So with that Spark data frame, I think it's elegant. So we'll start with like the imports. So these are really the three sort of key parts that we'll be demoing. I'm not importing the writer. In our demo, we're just going to look at the streaming source. So the data source is our top level class. And the name for our custom source is going to be GitHub. So I mentioned the sort of the key methods earlier on the slide. And with that GitHub, then we will be able to use this within our notebook further down. I mentioned the schema is an essential part. So most of these sources have a schema. So I think if you're using Kafka as your source, it's got like a key and a value, and I think a couple other columns. So for us, we're going to return the GitHub repository, the ID of the pull request, the title, author, and then some dates. And it's all going to be fake data, so it'll be goofy. And then this is the end of what we're going to implement for this top level class. So our implementation of data source, we're going to call it GitHub data source. And it's really these three methods. So this stream reader is what we're going to implement first, well, in this demo. And it's just saying this custom data source is only going to support streaming reads. So you'll get an exception if you try to do like a spark.read.format GitHub. I don't know what the exact exception would be, but it won't work because I didn't implement that other method. So we mentioned that this will be a partition-aware example. So there's that other method that we could have implemented called simple stream reader, where if you have a low volume source, then you can kind of take the easy button that way. So I'm going to do a quick question. So a number of people raised their hand when I asked if they had a custom data source. So I am curious for your custom source that you're hitting the API, or if you have to use some SDK, does it support the concept of partitions, and does it support the concept of offsets or sequence number, or maybe even timestamp? Is that, I forget who raised their hands, but anyone? No. No, okay. So that's an interesting pickle. That's an interesting pickle. And do you know why it's a pickle? So if you think about Spark, and if you're familiar with like the Kafka source, you can give it a starting offset. So if you're like, I need to, my job is messed up, I need to start back over and rehydrate the sink, you can tell it like, and again, if you're using Kafka, you can say, my starting offset is 1, 2, 3, 4, 5. So if your custom source does not support that offset concept, you can still like use this data source, but your use cases will have some limitations. So like you won't be able to, so for instance, let's just say you have a source that pulls in current temperature, and that's it, and you can't go back in time. Well, if you need to join with historical data, you're going to be out of luck. I mean, you're not going to be out of luck, but you're going to have nulls up until your event time matches the event time of your weather source. So the nuance, the API is fairly simple, but sometimes the reality of what you need to connect to can make it challenging. But you should still be able to use the API. But if your source doesn't allow you to go back in time or back sequence number, well, it's going to limit sort of the applications or use cases. And if your source doesn't have a concept of partitions, then you'll use that simple stream reader, and that one task might just have to be on a beefy core. All right, so let me keep going here. So the next class we define is our input partition. So for the GitHub source, we do have this concept of repos. So in our implementation, what we're going to do is we'll allow the user of the source to supply a list of different GitHub repos. And that's a way for us to partition the retrieval across many cores on the cluster. And then likewise, that GitHub API, I don't know if you remember it, but the last part of it was like the PR number. So that's a sequential number. So that gives us the offset concept. So for us, we can implement the partition and offset aware logic to its fullest. And then if we have like a stream-to-stream join, well, I don't know if we would need that for this use case, but then we could rewind it back in time and so forth. And for our partition, it's pretty simple. It's just what is the repo, what is the start. All right, so now the rest of the code I will not try to go too fast, but I'll try not to go too slow. So this is the class that we need to inherit, that data source stream reader. We're not using a simple one. When it gets initialized, I'm processing the options that are passed in. Actually, this token is not needed for this implementation, but the repos, that's the list of the GitHub repos that we're going to want to stream PR data in for. And then we're going to initialize the offsets to 0. Now, in this implementation I have here, it's just a toy implementation. I'm not actually going to be querying the source system to determine what the available offsets are. I've just got some logic that increments it by 3. Kind of, it assumes there's infinite amount of PRs, which frankly there probably are, close to infinite. And then that initial offset is a method that we override, and then we already have set those initial offsets. And then this is the logic that in this toy example, this is where in a real implementation you would go out and maybe see what the range of available offsets are and then calculate what you want to process in that micro batch. In this implementation, we're just saying we're going to add 3. This batch size is just a hard-coded value of 3. So that way this demo can go forever. And oh, I forgot to do one thing. Let me just run these cells and pray to the demo gods. All right, I got to backtrack a little bit. All right, so then there's a method to implement called partitions. And we saw that class that we defined earlier called repo partition. So that is just stating, like, for this repo or partition, here's the starting and ending offset. There's a function here that I'll just sort of fly through. So assume this is actually accessing the API and it's hitting my simulator, so it's not the real API, and then returning the data in the structure that we defined in that schema. So earlier in that first class that we implemented, there was a name method that we implemented, and there was a schema method that we implemented. So this data matches that schema that we defined. And then the read method is something you will implement as well. And that is using that, like, API, that fake API. And then it just is yielding the output. And then this last part, it doesn't have an implementation, but this method allows you, going back, I think a couple people were in the energy sector, so some of those devices might have onboard historical memory. So if you wanted to reach out back to that IoT device and say, you know, clear the memory, you would do it in this commit method, because by this point, you know your data has been committed to the sink. So it's safe to go back and say, yeah, wipe that onboard memory. And then this registers it. And then this code here is, well, it's going to be hard to see. So I've got a number of repos that we're going to monitor. And then I will display here. And actually, I'm going to run a couple more cells real quickly, and I'll come back to them. So we got about, I think, 20 different repos that we're going to monitor. And then we're going to display it, and then we're also going to sync this data to a table. Come on. All right, so it's starting up. Let's see what we got here. So in this raw data, it's kind of cool. We can start to see our work. Look at this. So in our source, we've got a custom data source, and you can see these offsets. So when it's first starting up, that's where I've got the sort of logic that sort of hard codes it takes the initial offset, which is initially 0, and adds 3 to it. But we can see for this first micro batch, we can see what those offsets are for these various different partitions. And let's see what else we got. So we got some data flowing through, and let me just close this up. And now we can see our fake data. All right, so this is sort of, I would say the beauty right here is like this spark.readstream.format, and then instead of using one of these built-in formats, we've got this one that we just created. Now I'm going to jump down a little bit, and I'll skip some of this, but we've got logic that is basically doing the same read stream, but this time it's syncing it to a delta table. And what I'm going to show here is, let me just make sure we've got some stuff in that table. Yep, so we have some data in our table. So I've got a little helper directory. So if you're familiar with Spark streaming, when you sync to a sink, be it a table or a Kafka or whatever, you provide a checkpoint directory. That checkpoint directory includes these like subdirectories. So there's a commits, there's an offset. If it's a stateful stream, you'll see another directory for state. And then if we look at the example offset files, we can see, well, I ran this earlier, but for the micro batch 18, we can see what the offsets were for our partitions. And then I had run this later, and we can see for the microbatch 25, the offsets had changed. So that is the custom PySpark API, but in a way, like we've sort of failed meeting the cultural goals of our startup. So reduce, reuse, and recycle. So does anybody have an idea what we should do next? All right, perfect. So publish the data source. So in this example, I put it together in a notebook. It's sort of easy to see, and we can have the display and fun stuff like that. But to really meet our mission of reuse, reduce, and recycle, we can put that Python file in a volume or a repo so that others can use it and pip install it or import it. And then, actually, I'm going to go back to my slides. I've got 4 more slides, if I can find them. And I want to get back to, let's see if this works. This might not work. Oh, I clicked the wrong button. So I've just got a couple final thoughts. There we go. All right, so for the developer, so the micro perspective, so decisions you need to make: read or write, stream or batch. Does your source support offset awareness? If not, well then that's going to limit sort of the ways you can use the data. Is the data volume high? Then you're going to want to parallelize that ingest using like the class that we used. And if not, you can use that simple one. For the macro perspective, if you're a manager or architect and you're thinking of how do we get this reused across the enterprise, and maybe it doesn't need to be reused, but in some industries you might want to roll this once. So you want to think like, how many other teams need this? How can we test this as an independent component, put it in its own CI/CD pipeline and version it? And then how do you manage changes? So at the macro level, and it really depends on the company and situation, but if there are, so I work with some clients where there's, 10 different data engineering teams. And if you all need to hit the same data source, if you approach this, with some thought and planning, you can just basically roll that once, let the rest of the teams use it, and then you got independent versioning and make your startup happy. Please remember to leave a little rating for me. And I'll be sticking around. I have to be somewhere at 7, but other than that, I'll be here to chat. And thank you so much.